students. In this series of lectures, we'll discuss on component-based software engineering. Now, the component-based software engineering, when we say, we'll broadly discuss three main topics: component and component models, CBSE processes, and component composition. We all know that in object-oriented programming, the objects basically can reuse certain codes. Particularly means when the inheritance is used, a property that is the object-oriented property called inheritance is used to get the functions details, or the objects basically can reuse those function definition, right? So those reusability property in object-oriented programming was essentially considered to be advantageous. But when as the time has passed, like the software developers or designers of the software system, they basically was looking for some independent reusable components which can be considered to be the actual part on the reusability part. That is because if any software is developed, any component or any part of the software is already available as independent component, then using that particular part of the software need not be again redesigned or rewritten, right? That existing component can be reused. So to have such an facility in the software design, the software designer basically were looking for some independent reusable components. But these object-oriented programming languages, though reusability is a part of the object-oriented, inherent part of the object-oriented programming paradigm, but it actually failed in having an independent component out of the reusability part of each objects. Okay, so this is there are some very important reasons why actually it has failed in such to have a independent reusable part. Um, Main actually the reasons, like they were actually too detailed and specific, and also it depends mainly on the applications, underlying applications. Okay, so the person who will be reusing a code through object-oriented programming has to have a detailed knowledge of the source code, and uh, so this inherently mean that those objects cannot be an independent, cannot have the complete independence. That means they cannot be sold or um, sold as the byproduct for entirely new system. Okay, that means they cannot be you can say uh, distributed uh, to different software development projects. Okay, so that actually that inherently actually failed the main objective of reusing the codes. So the software designer has come up with a uh, new uh, way of sharing, or you can say uh, sharing the codes, which is called as the component based software engineering. Basically, this entire field has emerged mostly in 1990s, and main objective of this particular component-based software engineering is to reuse the code. Okay, that is to have the independent component developed, which can be distributed to different software development projects where they can be reused. So, uh, unlike the objects in the object model, which for where they are too detailed and specific to certain projects, these components are actually more abstract. Okay, and they can be considered to be that is standalone service provider. That is, they may be considered to be independent. That means they can be considered as the standalone service provider. So they can exist as standalone entities. So definitely, the CBSE, the component-based software engineering, has become actually a process of software development, which can be considered as the you can say implementing and integrating loosely coupled independent components into a system. So this property itself, that loosely coupled independent components forming a system, has become an important software development approach because the software systems are becoming larger and complex day by day. Okay, so the CBSE essentials for this component-based software engineering essentials are the independent components. So independent component, already I have described what is an independent component, and obviously to merge those independent components to form the system, you need a proper interface so that the components can be uh, uh, integrated properly. Component can communicate in a proper manner. Okay, so it also means that uh, a kind of implementation where a component can be replaced by another component without changing other parts of the system. That means if a particular component needs to be replaced with some other component, then that particular component can be replaced without affecting the other components of the system. Component standards is another very important essential property or essential of the CBSE process, because the component standards facilitates the component integration, because to have the components properly interacting with one another, they must conform to some standard. This must be designed in some standard format. Okay, so they must be compliant to one another, then only you can basically integrate them with one another through interfaces. Okay, so this kind of, when such kind of compliances are there for certain components, then we can call those as the component model. So that is what actually the component standard means, or you can say component models. So when we can say having a components from a particular kind of component model, uh, we can say actually they should specify the kind of component interfaces that must be used. So definition of such interfaces should be there. Okay, and should also specify how components communicate with one another. And next essential part of a CBSE is the middleware. Middleware is very important actually, because the components are independent, they are abstract, so we need some middleware for the components to be uh, integrated with another component. Okay, another set of components, you can say, because that must form a standalone system. Now component integration basically provides interoperability. Okay, or we can say middleware also actually provides the software support for component integration. Okay, so we can say either way, that is, it provides support for component interoperability, or we may say that it actually provides the software support for component integration. So middleware are basically used for the components to communicate with one another. So it is the middleware which comes in between when the components are integrated, so that the components can effectively communicate with one another. So that is provided by the middlewares. Okay, so this support is very important for a system which is using the CBSE process. And the last essential part of the CBSE is the development process. The CBSE, basically CBSE must conform to a development process which is which actually supports the component integration. Okay, so we call it a CBSE development process. So we need to have such a development process where which is geared to component based software engineering. Okay, or we can say which is geared to reuse. Okay, so such a development process has to be there. So these are the four essentials of component based software engineering. So CBSE is a sound design principle that supports construction of understandable and maintainable software. Okay, so it is based on some very sound design principles. These design principles are like, components are independent, so basically they do not interfere with each other. That is, each component is considered to be a standalone part which can be which are actually completely independent from the other parts. Okay, so if we change some other parts, that is, this component is not affected, or if we uh, so it is considered to be, it's they actually do not interfere with each other. So component implementations are hidden. That is, uh, any that's component implementation actually can be changed without affecting the rest of the system. Okay, so that is why it is considered to be hidden. That is, any components implementation part, internal implementation, can be changed without affecting the rest of the system. So component always communicate through well-defined interfaces. So when component communicate with the other components, means they have to communicate through a very well-defined interface in between. And component platforms are shared and reduce development cost. So the platform for the components to be integrated is actually shared among all the components, and so it reduces the development cost of the system as a whole. Okay, so these are the basic design principles based on which the CBSE process is built. So components must have very components can have actually, because of its popularity, the way component based software engineering has evolved, some standards have evolved. Okay, so basic standards have evolved so that the component interoperability can be performed. Okay, that means the people can have by seeing the particular standard, people can know that this component is a what using in the software development in a which is using the software CBSE approach. Okay, CBSE process. So there are competing component standards that have evolved, like Sun's Enterprise Java Beans. It is a basically one particular standard where the Sun system has come up with some components which can be used or reused. Similarly, Microsoft's COM and .NET, Core Bus CCM. Okay, so but these components are these standards are actually, you can say, competing standards with one another. Okay, uh, so in it has development of these standards has taken an unfortunate turn in the sense that the multiple standards have actually hindered the uptake of CBSE, because CBSE, where we need the components to be reusable. So having different standards, actually the interoperability has become a major issue. That is, any component from one particular standard is difficult to make. Now it has become difficult to make interoperable with another component of other standard. Okay, so that has become a major issue here. So it has almost become impossible for those components, different standards, to work together. With the development of the CBSE approach, or the popularity of the CBSE approach, because it helps in reusing of the codes, there are some problems also that has emerged. Okay, so one is, when you have such components identified in the internet from some vendors, so trustworthiness is a very big issue. That is, how trustworthy is that particular component is. Okay, so because it is an abstract, the entire source code is hidden. You have only the documentation and the interfaces to be used, so you don't know each internal implementation. So trustworthiness has become a big issue. And another issue with the problem with the CBSE approach is that the component certification. So the component, suppose you have identified that you are going to use in your software development approach, so in that, who is going to certify the quality of that particular component? Okay, that is another issue. Then emergent property prediction. Suppose you have combined the components, so kind of property that the system as a whole will display or evolve is hard to predict. Okay, so that is another issue or problem with the CBSE approach. And when you have multiple components identified, so how do you make a trade-off analysis between the features of one component with another? That is the requirement trade-off, which is going to be more suitable to you. Okay, so that is another very big issue or problem in the CBSE. So these are some of the problems that emerge with the development of the CBSE approach or CBSE process. Okay. Now it is time to define the components formally. That is, what is actually a component? Component basically provides service. Okay, with least regard to the uh, to where the component is executing or its programming language. So the system in which the component you are using or executing, with it is actually it provides a service to the particular system, and it is completely independent, and it actually only provides the service through the interfaces. Okay, so it doesn't have too much to do with the other part, the programming language that you are using in the software development. With the other part, whatever programming language you may be using, the component is still independent. Okay, so component is an independent executable entity which is actually made up of, can be made up of one or more executable objects. Okay, so um, it can have one executable object, or it can have even more than that, but it is an independent executable entity. Okay, and for components to be used in a system, which the system that you are developing, the component must have a published interface. Why it is necessary? Because the interface has to be known and well documented so that people can use the component. Okay, and all the interaction with the system where you are using the component should be through that published interface. So Council and Hellman define the software component as is a software element that conforms to the component model and can be independently deployed and composed without modification according to a composition standard. So they defined it that the component belongs to a particular category, which is the component model, and those components are independently deployed and can be composed without modification according to the composition standard. So the component can be deployed and composed without any modification. Similarly, another software designer uh, has defined the software component as a unit composition with contractually specified interfaces and explicit context dependencies only. Okay, so basically contractually specified interfaces, it has the particular specified or defined interfaces, and explicit context dependencies only. Okay, so a software component can be deployed independently and is subject to composition of by third parties, because the software component is basically developed by a third party, okay, from whom you are taking that particular software component to use in your system. Okay, so uh, it has to be subject to the composition given by that particular party who has developed it, okay, to use it independently. So that is what the next person has defined. So these are some of the formal definitions. So some of the common component characteristics are defined here. So one of the this standardization, independent, composable, etc. So standardization is the first characteristic. What a standardization means is that the the component must conforms to a some standard component model. Okay, so basically when we say standard component model, the model which defines or elaborates the component interfaces, the component metadata, documentation, composition, and deployment. All these details are available with the model definition. So any component that you derive from a particular standard will bound by these standardized definitions given by the model, okay, or scripted in the model. Another characteristics is the independent. The component should be independent and should be possible to compose and deploy it without having to use other specific components. Okay, so it should be independently deployable. So if in case the component depends on some external services, then that should be explicitly mentioned or explicitly specified in the required interface specification. So the party or the people who have developed the components, that particular component has to specify such requirements, if any specific dependence of the component is there on some external elements. Okay. Another property or characteristics is the composable. So for a for a component to be composable, all external interactions that the component does should be publicly defined, should be via or through a publicly defined interface. Okay, that is an important requirement for the components. So we call it this characteristic as the component, the composable. Okay. Another characteristic says that the components must be deployable. Okay. So deployability means that self-contained components should be self-contained. So the components to be deployable, they must appear in binary form. That means they are um, the executable part. Okay, the executable programs which have um, that does not have to be compiled anymore. Okay, so it is the executable or the binary format of uh, the component should be available. Okay, so if a component has to be implemented as a service, then it has to be deployed by the service provider. Okay, so component must be deployable. The last one is documented. That is component characteristics. Documented means that component must be fully documented. Okay, so that potential users can decide whether or not the components meet their needs. So only by seeing the documents, the potential users who are going to use that particular component will know whether the components fits to their requirement, and that can be integrated in their system that is going to be developed. Okay, so uh, all syntax and semantics of the component interface for using the component should be specified or documented. Okay, component as a service provider. So we know now that component is an independent executable entity. Okay, and this entity need not be compiled. That is uh, to use because it is already a in binary format. Okay, so uh, similarly uh, to have, to use it as a service, to provide service. uh, Component service is basically offered via the interfaces. Okay, and all component interaction takes place through that interface only. And this interfaces, the component interactions uh, via that interface, is actually done in terms of parameterized operation. Okay, and that internal state of the component is never known. Okay, so it is basically abstracted out only through some parameterized operations. The interactions through the interface is done by the component. Okay, so internal state of the component is always hidden. So there are always two distinct interfaces for each of the components. Okay, one which provides the provides the services, that is provide interface. One another where which is called as the required interface. That means the incoming services for the uh, component to operate. Okay, so provide interface basically defines the services that are provided by the component to the other components. Okay, so you can see uh, these are the provide interfaces. Okay, and require interface basically defines the services that specifies what services must be made available to the component to execute as specified. So as per the description of the component, the way it should execute, for that it requires some input services, and those input services are provided to that particular component through the require interface. So you can see this is the require interface of the component. Okay, while when the component block diagram is drawn here, it is basically when we specify the provide interface, we specify a line with a round ball in front. This indicates that this is the provide interface. Similarly, for the incoming in the services, that means the require interface is indicated by a line on the other end. We have a half circle. Okay, this indicates that this is a require interface. So here is a component which collects some sensor data. Okay, that is actually, you can call, as you can see here, is a data collector which collects, say, some sensor data from array of sensors which comes through the require interface here. Okay, and here it is the sensor management is another input in the require interface. So there are number of uh, outputs which are generated or services which are provided by this component to other components. Okay, so these are in this output services are in the provide interface. So you can say the provides the add sensor, remove sensor, start sensor, stop sensor, test sensor, initialize, report, and list all. Okay, so now in the provide interfaces, the output that you can see uh, here, you can see this there is one output which is the service or that is provided is called as the report. Okay, report means whatever sensor data that comes into is goes as is produced as output as service to other components through report. Okay, so this particular provide interface, and list all is another sensor output in the provide interface that actually provides the sensors which are connected to this particular component. Okay, so all the information about the different sensors that are connected to this particular collector is provided through this particular provide interface, and rest are the usual provide interfaces where uh, which difference, like uh, outputs which are generated by this component or service generated by this component to the other components. Okay, and this is already I've explained. So these are the array of sensors that comes into here through this particular service require interface, and sensor management is basically done through this require management, this particular input interface. So that's what actually explained here. That is, the provide interface includes methods to add, remove, start, loop, and test sensors. Okay. The report method actually returns the sensor data that has been collected. The list all method provides the information about the attached sensor. Okay. And require interface is used to connect to the connect the components to the sensor. Okay. So component model is basically the standardization. So component model is the definition of standard for the component implementation. So already I have explained that there are some standard models that have come up for standardization. So one is EJB model, then COMPLUS model, .NET model you can say, Corba component model. Okay. So basically these all these standardized models, the component model, they have a well-defined interfaces specified. Okay. So the elements that should be included in an interface definition, basically those basically the component model specifies how interfaces should be defined and all the elements that should be included in the in an interface definition. The basic elements of a ideal component model is shown in this diagram. Okay. uh, so you can see the basic elements here: the interfaces, usage information, deployment, and use. Okay. So the interfaces must contain the interface definition, composition, specific interfaces. Okay. Similarly, usage information must have a naming convention, metadata access, customization. Deployment and use must have the packaging, documentation, and the evolution support. So these are all three basic elements of a component model that must be there for every standardization. So when we say interfaces, the it must specify how the interface should be defined. Okay. And the elements such as operation names, parameter, and exceptions, which should be included in the interface definitions. Okay. So all this should be defined along with the interfaces. That is the elements, the parameter names, operation name, parameters, and exceptions should also be defined in the interface itself. So similarly, the another component that we have, that is the usage information, the middle one. Usage information, this element. This is basically uh, to make it usable. That is how it is used. So so in order for components to be distributed and accessed remotely, they need to have a unique names and handle associated with them. So that particular name that it uses has to be globally unique. Okay. So that's what you get here. That is the naming convention and metadata access and customization is there. So the component name should be unique globally. No other component should have the same name. So deployment, the component model includes a specification of how components should be packaged for deployment as independent executable entities. So the specification about how it is going to be independent, that is the independent package for deployment, should be given in the deployment element. So it is the, you can see the proper documentation, packaging, and all this evolutionary support should be in the deployment and use. So these are the three basic elements of the component model. So as we already know, the support for executing components is provided by the middleware. Okay. And component model basically describes, has proper description or documentation of these middlewares which are provided with the components by that particular model, the component model. So there are two kind of the component model basically implementation provides two kind of you can say middleware supports. Okay, so one we can say the platform services, another is the support services. Okay, the platform services actually uh, enables the components to communicate and interoperate in a distributed environment. So these are the fundamental services that must be available in all component based system. So the platform services, that is for the interfaces, is the way it provides the interoperability or the communication among the components. Support services are actually the tertiary services. You can say uh, like authentication, etc. Okay, so uh, that may be required by different components from time to time. So these are it may not be, these are non-essential services, but they are the support services which are provided by the middleware. Okay, so like many components require authentication to ensure that the user of the component service is authorized. Okay, so this comes under the support service. So the middleware implementation implements the component service and provides interfaces to these services. Okay, so the middleware basically implements the component service. That is the mandatory implementation of the middleware. That is which provides the communication part of among the components. Okay, which and this provides the interfaces for these services. So this is the diagrammatic representation of support services and platform services. Support services, as you can see, is the component management, transaction management, resource management, concurrency, persistent, security. So these are the support services, and the mandatory platform service are the addressing, then interface definition, exception management, component communication. These are the platform services which are provided by the component model. Okay. So the CBSE processes are basically the software processes that helps the reusability of the components. Okay, so whenever we use the software development through some reusable components, we basically use the CBSE process. Okay, so it takes into account the possibility of the reuse. Okay, and the different process activities involved in developing and using the reusable components. So there are two kind of reusability that comes into a picture while using the CBSE process. One is the development for reuse, another is the development with reuse. Development for reuse, the first here you can see this one, development for reuse, is the process concerned with the developing of the components and the services that will be reused. So the process which involves developing of the independent components for reuse in some other applications. Okay, so when a reusable component is built from the scratch, it is the development for reuse, and another is development with reuse. Now when you use an independent component, a deployable component, to develop a new system, a new application system, then it is the development with reuse. Okay, so we can see in the diagram here, this is the CBSE process diagram where you have the process called the CBSE for reuse, CBSE with reuse. Okay, and these are the component acquisition. So CBSE for reuse, that means when you develop a particular component, actually most of the CBSE for reuse actually does what, actually it generalize an existing component. Okay, so when you can have an existing component taken into this one, to develop or make it more generalized one in a CBSE for reuse, or when you develop a new application where you use a particular component, it is the CBSE with reuse process can have the composition for there. So process step, the component acquisition takes the component from the component repository through component management. Okay, so it asks for a particular component to either to restructure it in the CBSE for reuse or to use it in the CBSE with reuse, and this process must come through the component management, which will get it from the component repository. Okay, and provided there is a certification in the component certification part, it will check for this. Component management will definitely check for the certification of the component and for the purpose for which it is being asked to be used, and then component acquisition will get it and provide it with the proper service. Okay, and there are, you can see the different actors which actually deals with this particular uh, these activities. So in the CBSE with reuse, you can see the designer, integrator, maintainer are the actors which are involved with the CBSE with reuse. Similarly, in the acquisition part, component acquisition, actually librarian, vendor, broker are involved in the component acquisition. Okay, so uh, component management, maybe the librarian who is managing the components. Okay, whenever it is being asked for by either of these software, CBSE for reuse or CBSE with reuse. Or similarly, component certification part is actually the actor involved with is the local or the external certifier. Okay, and you can see the CBSE for reuse has the actors involved are the domain analyst, designer, implementer, maintainer, market analyst who can actually go into developing a new independent component for reusing in other systems. Okay. So uh, that description is given here, whatever I have said there. That is, the component acquisition is the process of acquiring components for reuse or developing into a reusable component. Okay, it may involve accessing locally developed component or services or finding these components from an external source. So component management activity is concerned with managing a company's reusable components, ensuring that they are properly cataloged, stored and made available for reuse. So this is the component management who makes a catalog of all the components available and stores in a proper format in a repository, and whenever it is being asked for by these activities, and it provides those components. Component certification, the process of checking a component and certifying that it meets the specification. So I told you already, that is the component certification is the process which actually checks the authentication or the whether the particular component meets the specification for which it is required is identified by this certification method. Okay, so this is the process of identifying the component uh, for the appropriate task according to specification. Okay, so this is done here with the component certification, as you can see. So the key points that we have discussed till now: CBSE is a reuse based approach to define and implement the loosely coupled component into systems, and the component is a software unit whose functionality and the dependencies are completely defined by its interfaces. A component model defines a set of standards that component provider and composers should follow. The key CBSE processes are CBSE for reuse and CBSE with reuse. Thank you.